previous mathematics courses, you have studied radical expressions and fractional exponents. In these courses, you learned that radical expressions can be rewritten with fractional or rational exponents using the following property. The nth root of a raised to the m equals the nth root of a all raised to the m, and also equals a raised to the m over n. Also remember that the nth root of a is equal to a raised to the 1 over n. Using this knowledge, we can rewrite radical expressions. For example, write the following radical expression with an exponent and simplify if possible. The cube root of 9y squared. First, we will square what is inside of the radical, then we will rewrite the radical expression using fractional exponents. So, the cube root of 9y squared equals the cube root of 81 times y squared, which equals 81 to the 1/3 times y to the 2/3, or 3y to the 2/3. The ability to rewrite radical expressions with fractional exponents is helpful because it allows us to solve logarithms more easily. If the logarithm contains a radical expression, we can rewrite this using exponents, and then using the log of a power rule, which you learned today in class, we can move the exponent to the front of the expression and then solve. The log of a power rule is log base b of x raised to the k equals k times log base b of x. So for example, if we have log base 2 of the cube root of 256, we can rewrite the cube root of 256 as 256 to the 1/3. Now, using the log of a power rule, our equation can be rewritten log base 2 of 256 to the 1/3 equals 1/3 times log base 2 of 256. Now we can solve log base 2 of 256 and multiply the answer by 1/3. Since 2 to the 8 equals 256, then log base 2 of 256 equals 8. Therefore, 1/3 log base 2 of 256 equals 1/3 times 8, or 8/3. In the task you did today in class, chopping logs, you learned about 3 rules of logarithms that allow you to expand and contract logarithmic expressions. As we will see in future tasks, being able to write logarithms as equivalent expressions will allow us to solve them more easily. In this section of your assignment, you will be using the 3 rules or properties you learned in class to expand expressions of logarithms. Here are the 3 rules you learned. The log of a product rule, log base b of x times y equals log base b of x plus log base b of y. The log of a quotient rule, log base b of x divided by y equals log base b of x minus log base b of y. And the log of a power rule, log base b of x raised to the k equals k times log base b of x. As you will see in the next 2 examples, we can use these rules to expand logarithmic expressions from one logarithm into multiple logarithms. For example, use the rules of logarithms to expand the expression as a sum or difference and/or constant multiple of logarithms. For our first example, we have log base 3 of 12 times y cubed. This is a logarithm of the product 12 times y cubed. So to expand this, we will use the log of a product rule. Thus, log base 3 of 12y cubed equals log base 3 of 12 plus log base 3 of y cubed. Notice that we can also use the log of a power rule on the second logarithm in this expression. So log base 3 of 12 plus log base 3 of y cubed equals log base 3 of 12 plus 3 times log base 3 of y. For our second example, we have log base 5 of x divided by y squared times z. We start by using the log of a quotient rule, so log base 5 of x divided by y squared times z equals log base 5 of x minus log base 5 of y squared times z. Now we notice that the second logarithm is a log of a product. We can use this rule and then distribute the negative sign. So, log base 5 of x minus log base 5 of y squared plus log base 5 of z, which is equal to log base 5 of x minus log base 5 of y squared minus log base 5 of z. Last, we use the log of a power rule on the second logarithm. So log base 5 of x minus 2 times log base 5 of y minus log base 5 of z. Be careful with exponents. Notice that in the first example we did, the exponent was only on the y. The order in which you apply the rules of logarithms will be different for a logarithm where the exponent is outside of a set of parentheses, such as the following: log base 3 of 5x all squared. In previous tasks in this unit, you learned how to use the definition of a logarithm to convert logarithmic expressions to exponential form and vice versa. The definition of logarithm is shown. For all positive numbers a, where a is not equal to 1, and all positive numbers x, y equals log base a of x means the same as x equals a to the y. In this section, you will use this definition to help you change between the two forms. For example, convert each logarithm to exponential form and each exponential expression to logarithmic form. First, 5 to the 7 equals 78,125. In logarithmic form, log base 5 of 78,125 equals 7. Second, log base 2 of 1/16 equals negative 4. In exponential form, 2 to the negative 4 equals 1/16. Remember that the base of the logarithm is the base of the exponent.